So for our final day of notes in this inequality unit, we're going to talk about absolute value inequalities. The nice thing about this is really it's only coming down to one key thing, and that's that you have to know how to rewrite these absolute value inequalities into some of the inequalities that you've already been solving this whole time. So we're going to talk about the two scenarios and two cases, and then we'll go from there. So when we're looking at absolute value inequalities, there's two scenarios. It's really based on the inequality symbols. Either the absolute value is less than some number, or the absolute value is greater than one number. And so right now, for the first one, we'll look at the absolute value being less than something. And so if you think about what this absolute value for an example is saying up top here, the absolute value of x is less than 5, meaning the distance x is from 0 is less than 5 units. So that means x could be things like, 1. It could be things like 2. It could be things like 3. It could be 4. It can't be 5 itself, okay? But it could be any of these values because all of these values are less than 5 units away from 0, okay? 0 itself is even that. So and then we go this way, -1, -2, those are all within 5 units away from 0 or less than that. And then again, we get to -5, and -5 is exactly 5 units away from 0. And so if we look at just how this graph came out to be, this resembles one of our and compound inequalities, okay? And so the thing to remember from this is when you have a symbol like this and we're talking about the less than or less than or equal to, think about the sound of this. This is implying that this is an and, okay? And so really the key to solving these inequalities is when you look at the compound inequality that we want to write, it's based on that symbol. And so if you have an absolute value that is less than some number, then what you need to do is you need to take your absolute value inequality, and what you're going to do is you're going to take what's inside, whatever is inside there, and we are simply going to say it is less than that constant there that we had. But then the other part to this is we are going to also put at the other end that it is greater than the opposite of that, okay? And so really what we've done here is we've taken this absolute value inequality and rewrote it as an and compound inequality. And so to solve this inequality, rewrite it as a compound and then solve it just like you've been solving it this entire time. So steps that you're going to want to follow here, okay? Step 1, you're still going to want to isolate the absolute value. This is one of the first steps that you did in the equation unit with these absolute value equations, and it's the same thing here. You're going to want to, step 1, isolate the absolute value, okay? It doesn't matter what's inside of it. You need to get the absolute value all alone first. After that, step 2 is, based on the inequality symbol, you need to decide if this is supposed to become an and compound inequality versus should this be rewritten as an or compound inequality. And again, that's all based on looking at the symbols. If it's an and, okay, that's going to be because the less than or the less than or equal to. If it's an or, that will be because of the greater than or greater than or equal to symbol, okay? So once you have that decided then it's about rewriting then in step 3, rewrite this thing as that compound inequality. Step 4, solve it just like you did all the other compound inequalities and then graph your solution at the very end. So in this problem here, we're just solving this absolute value equation. First thing is we need to get this absolute value all by itself. So if I get rid of that 3 by subtracting it, and now once I've solved it, I can identify that this is supposed to be an and compound inequality based on that less than symbol. And so I can rewrite this then as take what's on the inside of that absolute value is less than the number that I had there, and it's also greater than the opposite of what was over there. So I rewrote this as a compound and inequality. And in this case, this one's already actually solved for us. Don't have to solve it. It's already got x isolated in the middle. So going to graph it, -9, +9, x is greater than that, and x is less than that +9. So again, compound and inequality typically has a graph where we're shading in between those two numbers. Again, same idea, same steps, same things to look for here. Isolate the absolute value. In this case, check. I'm done. Step 2, decide if it's an and or an or. Well, this is a less than or equal to 2 symbol, so this would be an and. And then now we're rewriting this as our compound and absolute value. Take what's on the inside of my absolute value. It is less than or equal to that number over on the side there. And it's also greater than or equal to the opposite. And so now that I've rewritten this, I can now solve it just like we solved all the other ones in the past unit lesson. So if I'm going to get x by itself, I need to subtract 4. Whatever I do to the middle area of this compound and inequality, I have to do it to the left and the right as well. And so it appears for this one, x is greater than or equal to a -6, and it is less than or equal to a -2. And so you go to your graph, -6, -2, x is greater than or equal to -6, and it is also less than or equal to -2. So again, same steps, just you need to make sure you are rewriting this to the correct compound inequality. Okay, with the second one then, again, we're talking about the two possibilities, the less than symbols versus the greater than symbols. And so if I look at this one here, kind of how we examined the first one, if I'm looking at this as the absolute value of x is greater than 5, that means the distance x is from 0 has to be more than 5 units away. So everything that's more than 5 units away from 0 would be all of these things after 5, so like 6, 7, 8, 9, 10, 11, 12, so on. And everything on this end also, -6, -7, -8, -9, -10, all of those numbers are also more than 5 units away from 0. And so this resembles one of our OR compound inequalities, okay? So again, we're looking at this symbol here. This is the greater than. And even after that, I just said it. If you want to actually just hear it again, if you say greater than, okay, it's about hearing this part there. That's going to imply, again, we're talking about an or. So with this one, we're not rewriting it as an and compound inequality. We're rewriting this as an or compound inequality. And so when you have this absolute value that is greater than some constant, some number, you're rewriting this as an or. So really, you're actually rewriting this into two individual inequalities that are then connected with this idea of or. So first thing, take what's on the inside, and it is greater than that constant value. Or take what's on the inside, and now we're going to flip the sign so that it is less than now and put the opposite. So if you can rewrite this into those two inequalities that are together an or compound inequality, solve each of those, you will then have your answer for this absolute value inequality. So this still follows the exact same steps we talked about before. Things like you need to work at isolating your absolute values. So again, I have to move this 20 to the other side. My absolute value of x is greater than, and I have a -13 plus 20 would be a 7. Now that the absolute value is isolated, I can decide if this is supposed to be an and versus an or. So this is an absolute value is greater than a 7, so this should become an or. Step 3, rewrite it. So I'm going to again take what's on the inside. It is greater than 7, or take what's on the inside, and it is less than the opposite, negative 7. So if I have that now, it's already solved for me in this case. So I got negative 7, positive 7. X is greater than positive 7, or x is less than negative 7. So again, these problems here are mainly going to come down to, 1, can you follow these steps to isolate the absolute value first, and then rewrite it as a compound inequality? And then secondly, can you solve these just like all the other compound inequalities you were doing before? So again, it's just going to take little things, step by step, getting your absolute value alone. That was the first thing you had to do. Move the 5. Nothing changes about this. It's still got a 2x minus 8 inside the absolute value, and now it's got a 6 on the other side now. Okay. After that, isolated that. Now I look at the absolute value compared with the other side. It's greater than 6, so this should be an or. So I am, again, going to take what's on the inside. It is greater than or equal to 6, or take what's on the inside, and it is less than or equal to the opposite, negative 6. So I've rewritten it as this compound or inequality. Now I'm going back to solve each one of them individually, one at a time, just like we did the ors before. So I'm going to add 8. 2x is greater than or equal to a 14. Divide by 2. X is greater than or equal to a 7. Or add the 8. 2x is less than or equal to a 2. Divide both sides by 2. X is less than or equal to a 1. So again, I have my solution for my or. X is greater than or equal to a 7. So there we go. Or x is less than or equal to a 1. And there's your solution. So again, these are just compound inequalities. You just have to make sure you've rewritten it correctly into the right one. Some of these problems, though, you are going to have to do a little bit of thinking and problem solving, because sometimes you're going to end up with answers that aren't entirely correct. They're not entirely incorrect. They're not entirely false. But you are going to have to do a little bit of thinking for yourself to realize what the actual answer is in the end. And so when we're going through our steps, just like we did before, things like you got to get the absolute value by itself. This 3 is multiplying. So if I divide both sides by 3, I get x minus 6, and this absolute value is greater than or equal to a negative 3. Now, before we said an absolute value can never be a negative. However, in this case, an absolute value is definitely greater than a negative 3. Like the absolute value could be, in the end, a 5. That's greater than a negative 3. So you can still continue this process and continue this solving. So it's going to take a little bit of just sitting with it, thinking about it. Does it make sense? Is it possible? And then you can keep going. So if I isolate it, this is an or. So I take what's on the inside, greater than or equal to a negative 3. Take what's on the inside, less than or equal to the opposite of that. Okay? So now watch what happens here. Okay? Watch what happens. X greater than or equal to, if I add 6 to both sides, I get a positive 3. Or if I add 6 to both sides, I get x is less than or equal to a 9. Now watch. 3, 9. X is greater than or equal to a positive 3, or x is less than or equal to a positive 9. Now remember, the ors, I only care about when we were doing these compound inequalities. The ors are, I only really care about where things got shaded in one time. They can get shaded in twice, but in the end, my solution is everything that got shaded in once, at least once. And so according to this graph, it appears that everything is getting shaded in. Everything on this is actually getting shaded in. So that's why our solution is actually all real numbers. So again, you're going to have to make sure you're thinking through these things so you can actually make sure you're getting the right values. So the last one here, if you're isolating these things like we started off with all the other ones, you got to make sure you're isolating it. Now let me ask you here. We said in the last slide, it is possible for an absolute value to be greater than a negative number because it could be positive. However, in this case, we're saying this entire absolute value, no matter what we plug into this thing for x plus 12, the absolute value of that right there would be less than a negative 3, implying it will always be negative. That's not possible. That can't actually happen, okay? And even if you went through this problem and finished it, even if you decided to continue this problem on, take what's on the inside, less than or equal to a negative 3, take what's on the inside, it's greater than or equal to the opposite of that. If you went through and solved this, problem, negative 9 is greater than or less than or equal to x, which is less than or equal to a negative 15. If you did this problem, negative 15, x would be less than or equal to this, and negative 9, x would be greater than or equal to that. This is an and, though. I'm trying to look for where this graph got shaded in twice, and apparently that didn't happen on my graph. That's why there's no solution. So again, no matter what you end up doing, you'll either catch that kind of scenario here when it happens. You can't have an absolute value that is less than a negative value. That's implying the absolute value will always be negative, and that's not true. Or if you keep going through your process, you're going to end up with something that doesn't make sense with how we've solved and compound inequalities in the past. You need a double shaded in region for it to work. In this case, it doesn't. So with these compound inequalities that you're rewriting from these absolute value ones, we are doing the same things you did before. The same steps, the same solving and same graphing, but it's just that kind of starter to this problem. You have to make sure, again, you have to make sure you are isolating the absolute value. After that, you have to make sure that you are deciding and rewriting this thing correctly into the correct compound inequality. After that, the solving is everything we did before, okay? So make sure that you're getting this done. Make sure you're taking time to get help if you need it. If you are not able to get through this, please, I encourage you to stop by either on Wednesday morning before school or stop in with one of the other math teachers. Mr. Leffler is right next door in FH 101. He is available for help. And so if you can't figure it out, which I think everyone should be able to figure this out, it's just simply rewriting. Please make sure you are getting help somewhere and communicating that. But otherwise, we will see you then on Wednesday for the group worksheet. And then the next class after that, we will have the second quiz. So again, the next class we have, I know periods 1 and 6 have the group worksheet on Wednesday, I believe. And actually, I think now that I think of it, I think period 7 also does. So just make sure, again, you're getting ready for the next thing, you're able to contribute to your group, and that you're getting your homeworks done. And if you need help, make sure you're coming in to get it. So we'll see you all later. Make sure you guys and girls are getting your stuff done, and make sure you're taking care of your things. But otherwise, we'll see you then.